So when you've got just one bubble, the sphere is the most efficient shape. But as we add more bubbles, we see the geometry changing. So in this case, we've got 4 bubbles, and you can see them meeting at a point. But put a shape in the middle, we don't get a spherical bubble. We get, in fact, a little tetrahedron. With 4 faces, they're not exactly flat, they're parts of spheres. But each time, the bubbles are trying to find the most efficient shape for the arrangement of bubbles. So now we've got 6 bubbles, we've got a little cube appearing in the middle. This is nature's laws at work. The universe is always trying to find the most efficient solution it can. And as we pop them, the bubbles change, finding the most efficient, until we're left with a sphere again.
It has no choice.
But what's most remarkable is that those solutions are so often neat geometric shapes.
Wow, that's a dodecahedron. That's fantastic. And they're almost perfect pentagons, aren't they? That's really surprising. They're not bulging really very much at all.
That's right. That's right.
So 12 bubbles around make 12 faces, and the most economical shape that they can make, the lowest energy, is the dodecahedron in the middle.
Yeah.
The soap bubble reveals something fundamental about nature. It's lazy. It tries to find the most efficient shape, the one using the least energy. But each time one pops, they're always trying to assume the most efficient shape, the one that uses the least energy. And what they're doing is trying to minimize the surface area across the whole bubble structure. But if we in fact make each of the bubbles the same size, a rather magical shape starts to appear. The hexagon.
And when you pack lots of hexagons together, the pattern that spontaneously emerges is the familiar sight of a tightly ordered honeycomb.
So when we see that pattern at the heart of the beehive, it is in fact echoing some of the fundamental geometric rules of the universe.
This way. Each cell is exactly like the others, 6 walls meeting precisely at 120 degrees. And every honeybee, everywhere in the world, knows how to build these shapes. The bees' primary need is to store as much honey as they can, while using as little precious wax as possible.
The bee's honeycomb is an amazing piece of engineering, but why have they evolved to produce this hexagonal pattern? Well, actually, they don't have too many choices. If you try to put pentagons together, for example, they just don't fit together nicely, or circles leave lots of little gaps. If they want to produce a network of regular shapes which fit together neatly, then you've really only got 3 options. You can do equilateral triangles, or you could do squares, or you can do the bee's hexagons. But why of those 3 does the bee choose the hexagons? Well, it turns out that the triangles actually use much more wax than any of the other shapes. Squares are a little better, but it's the hexagons which use the least amount of wax.
It's a solution that was only mathematically proven a few years ago. The hexagonal array is the most efficient storage solution the bees could have chosen. Yet with a little help from evolution, they worked it out for themselves millions of years ago.